I'm I'm on screen. It's not right.
Oh, it's so creepy, isn't it? It's pretty.
No escaping.
Oh shit! Then you know that.
They have seats. Not enough seats. Should I get rid of it? It's talking about too many people. There isn't seats. We didn't even large room.
Is that
Hmm?
this?
So many. Oh, it's
Cameras.
Different cameras.
This is,
I know it's really weird.
but it's not really.
I think that's wrong.
I like that.
Take this. Yeah. I'm going to the lack of check.
What? Lack of joke.
I was predicting jacket cakes
No.
provided by Snowflake.
We should have. Teddy can organise the refreshments next time.
I feel like Snowflake should have like Snowflake
That's true. They're bloody.
tweets that
Their user groups have a lot of funding. Cool.
Fly, be invited to guess. Sorry, this is unrelated.
Different meeting. Don't cross channels.
And unfortunately,
Yeah.
I think we'll give it 1 or 2 more minutes.
The AI sent. I think it's from Movement or.
Can you all hear us
Okay.
outside?
Yes, I can.
it never
Hello.
feels to me. It's invisible.
Don't worry.
Oh no, I'm not.
Oh wait, you've started. This is yours. Oh, okay. When I share, okay.
Can you all hear us from outside?
Yes, we can hear you and we love the camera action. Very sophisticated.
Ranting.
Okay, that's great in that case. So this is a new initiative. We call it Pint-Sized Science, just informally to share the teachings and learning among the many expertise we have in the team, and we're making it open to all other colleagues and partners from KCL and KCH as well. So thank you, Lawrence, who is our principal data engineer, kicking off on Snowflake. Some of us can't make it, so the meeting is recorded for their benefit. So over to you, Lawrence. Thank you.
Oh, cool. Oh, shared. All right. I'll begin. It's a bit hard to target this at everyone because there's a range of abilities and skills, but I'm trying to briefly touch on why Snowflake's great for the trust and what it brings, and what it will sort of take over potentially. So what it's currently taken from the trust and what it adds in the future is kind of the focus. So a pint-related photo. It's more of a Stein. The more liberal European airports allow you to drink vast quantities of beer in one sitting for unreasonably low prices. So I've touched on that already. So what does the current GST data architecture look like? There is a large array of somewhat well or less well organized databases that sprung up over time for various reasons. Some add new capabilities, like Elastic's very good for free text stuff, but a lot of databases were created because someone wanted to do something and whoever owned the main database wouldn't give people rights.
Had her hand up. Sorry, Lawrence.
Oh.
Yeah, sorry, I was just going to ask if you can that screen be shared?
The
yes.
We
recording.
can't see it.
Oh shit!
Yeah.
Oh, sorry. Oh no, it's because it's a bit confused. Oh wait a sec. That was a very valid point. Okay, can you see that now? I assume.
Yes, we can
Yes,
see
we
that
can.
now.
Okay. Sorry, there's a confusing setup here. So yeah, going back, you can see there's a range of databases. These have sprung up over time as people have needed to create their own environments to do their own data transformations or use it for their operational purposes, etc. And then, as such, you see on the right, this is what AI is tend to do is like, oh, the volumes of data and the requirements to do big transformations lead with lots of strange random stuff. A lot of this isn't really well audited. I don't know how easy it is to audit stuff in EDW. I imagine not very. It's a little bit out of control. Stuff like Sound Designers of its time, it's a bit long in the tooth. If you're wanting to do more complex or sort of reviewed code, software engineering type approaches to doing stuff, Sound Design is crippling you on that front. It's not designed to integrate with stuff like Git or whatever. If I wanted to push back transformations into the EDW, this doesn't scale, it's slow, it's not very secure, having to move large volumes of data around. You get the idea. It can be somewhat simplified. This is not a true, like, there'll be things here which won't be integrated. So like, the idea is that you can bring things into one place. You don't need everyone creating their own database to do a given task. And then on top of that, there are lots of new things that can be done in Snowflake as the trust goes into the cloud. So here are a few. You can share data with other institutions. You can do more advanced Python type transformations or data science approaches. You can run fancy containers. You're also not constrained to the size of your disk attached to your database, because this can scale essentially infinitely, or as much as Microsoft can have storage, which is lots. Does that make sense? Nice. So there's also stuff on top like governance, scale, security. This all comes for free as part of this platform. Where did Snowflake come from, and how did it become a big-ish deal? It started in 2012 by a couple of French dudes who saw the rise of the cloud and the current equivalent services that you could do for large data warehousing or transformations. It's quite limiting. Redshift was the biggest competitor at the time, which is an AWS product, which is famously not very fun to manage. And they figured out a new way, which I'll go through in a sec, of a new paradigm of doing large data warehousing, big data type stuff. And then there's a sort of duopoly of Snowflake or Databricks being the natural competitors in the space. Very quickly, touching on some more technical stuff. There's two types of databases. There's OLTP, which stands for Online Transactional Processing Database, and OLAP, which stands for Analytical. And they have two vague different use cases. OLTPs for transactions. So if you're a bank, you say, like, I gave Teddy £10, and that'll be recorded. It's very fast to do single line lookups or changes or entries. Seem like a patient has a blood recorded, a blood result recorded. For doing lookups or single changes in the database is very fast. It's very high throughput. You can handle many thousands of transactions at once, but the volume of data you're actually editing or touching is very small. OLAP databases allow you to do millions and millions of rows and do huge scans and do large data type use cases, but the number of transactions you can handle is comparatively slow. So you will handle 3, 5, 10 transactions typically on one node, but you can touch much more data. How the current EDW works is you have a sort of classic SQL Server type setup. So you have a single user or a set of users who query a database. This database is attached to a spinning disk or a solid state drive, functionally the same. You get your results. That's fine if you're one user, but as we're growing as a team, or the trust's data users are growing, you have many more users who do many more loving queries. And then because the data is tied to where it sits, the database is sad, and this is already a problem in EDW where Ben will do some clever data science stuff, and then I'll try and we'll do like a small lookup or whatever, and it blows up. Also, the volume of data that Epic produces is so vast, it doesn't really scale. Quiz for the room. Does anyone know how you try and mitigate it with a classic sort of OLTP type? How would you try and scale it?
Load sharing,
Yeah.
scheduling.
So there's two approaches of sharding, where you'd split the data out into so you have patient A, B, and C. You can see my mouse. Or you could have what are called read-write replicas. So you have one write node, and then it carries a log of what gets written to it, and these get copied out to separate read replicas. all this stuff is a faff to manage, it's quite fiddly, it's expensive. You're also copying the data for each node or each location it sits at. So it doesn't really work, for what we want to do. This is a bit too much detail. The way these databases work is they have essentially a disk, as you can see, and data split up into 8 kilobyte chunks. So this will contain 8 kilobytes worth of rows, and it's chunked out and spread across a disk. You can then have indexes, which will tell you exactly where your platter and head needs to travel to effectively, but you're very much tied to each disk, roughly. This kind of change, well, the big innovation in Snowflake in the 2010s was that you had AWS with S3 buckets, so object stores, and Microsoft blob storage, whatever GCP calls it. And you, instead of thinking of data as 8 kilobyte chunks, you just think of stuff as objects. So I don't know, the Great Gatsby is the recurring theme, but it could be a blood result or, you know, a database. If you want to put that to the cloud, instead of chunking to 8 kilobyte chunks and storing it in your whatever data store, you just shove the file. It sits there when other people want it. Essentially, you're spreading your concerns about scaling to Microsoft or AWS, who have much more infrastructure, much more complex teams who can manage this for you. So you just think of stuff as files. And this is kind of, I just wanted to touch on, this is what kind of makes Snowflake very different to the classical SQL server, is that you're pushing your data to blob storage. So your data is being split up into larger files, so the volume of data you can handle is much bigger. So if we look here, this is our S3 blob storage. So Snowflake internally splits up into its files into compressed files called flacon de neige files. The more French of you might figure out what that means. But if you're a user and you want to make a query, you can essentially, you're using all the scale that comes from the cloud. So these are AWS logos. So this is EC2. So you have a compute instance and S3 storage, and these can pull data from the relevant files and return a result. The cool part is, as more people come along and want to do more complex stuff, we can try and use the same node, but you can do clever things and actually scale these out. So you can create a new compute node, and then your queries can scale. So you're no longer tied to just having one device being able to handle the data. The compute and the data's been split in a way that wasn't possible before with SQL Server, unless you're doing weird replica type stuff. If you want to do a really complex query, you can then just use a bigger computer and do much more complex stuff. So all of this, especially when you start using data in Epic, which is billions of rows in the flow sheets, tables, it comes much more manageable. So the next few rows are a bit more nerdy, but the way Snowflake and modern data warehouses work is different to this classical row-based storage. So physically, in SQL Server, when you have a row, it's split up like this. So data spread across in lines. And if you're wanting to select, let's say we want to select this customer name column, to do so, we have to scan physically through each row and pick out this. We have to scan through, pick out this 3, this 2, this 4. There's no way to do this efficiently, just because how the data is physically stored. With a lot of the work we do, which is data sciencey, data analytics approach, we mostly care about columns and less about rows. We're not doing transactional workflows, the analytical workflows. So modern data warehouses store stuff in columns. So if we want to just select the custom name, it's physically stored as this block here, if you like. And that's the main difference in terms of paradigms. You can then do some clever stuff on top. So although your data is stored in columns, it's then split up further into groups. So you'll have rows. Imagine this is 9 rows, but this is done across tens or hundreds of thousands of row groups. So you can then store statistics about each row group. So although this is boring, you say my row group contains patients 1 to 5. You can say my row group contains full blood count results with the values between 90 and 110 grams per deciliter. So you can begin to sort of have index type structures attached to the underlying data, which allows you to do much faster scans of data and do things at scale much more quickly without having to handle indexes and other data structures. Like you go in further, you can go into compression. So with the horrible volumes of data that Epic produces, you can now compress things down in using this columnar approach. So I mean, these are just a few compression techniques. So run length encoding, dictionary, bit packing allows you to store all this data in a compressed form, so you can actually process it faster. So yeah, you can compress more, you can pull the data more quickly, and as a result of things being columns, you can process it much faster. So we've talked about being able to scan columns and compress things. We get our indexes for free. You can also, because you're doing stuff in columns, think about vectorization. So you can use more advanced CPU instructions, so single instruction, multiple data, SIMD type instructions that allow you to process data at scale much more. Okay, so Snowflake is in essence a very swanky data warehouse in the cloud, which is nice to manage, etc. But it also adds a lot more. So I've spoken about how the data warehousing stuff can be done at the trust more quickly, but there's a lot it adds on top. So spoken about the data warehouse, I'll talk about all the other fun terms you might have seen up to this point. On data warehousing, I think it is quite cool that we do get things for free, like data democratization. The fact that we're all in one place means that we don't have to go to databases, push the results somewhere else. We're in control. We can also share stuff outside the trust. We can scale. We have more control. You might have heard the term data lakehouse. I don't know if anyone has. Can you think of an example that we might want to use it for? The idea of a data lakehouse is that you have your structured data and your unstructured data in a common place, and you can handle them much more closely. So instead of having to pull in fact, I'll just show you my example. Instead of having to pull like a DICOM image from a PACS database and some structured OMOP data from the OMOP database, they can just sit in the same place. So this is some dummy-ish code or valid-ish code for how you could maybe handle or inspect a chest X-ray DICOM image. So this is, you could instead actually have a clever language, not language model, machine vision model code inference here. In this instance, we're just averaging the pixel values, and then if it's between a certain intensity, give a true or false Boolean value if it's normal. But you can create these type of functions which you can call from SQL. So let's say I have a database just DICOM images and some patient metadata. You can first of all join said table to other tables and get out the patient age. But then you can also call machine learning inference from a SQL query, which sort of seems a bit weird, but is very cool. And then you can get, a result. So we've got a DICOM path, and then we've got patient metadata and also an inferred result. And that's the really cool beauty of stuff you can do in their lakehouse type pattern, which isn't really possible to do at the trust at the moment. You have to faff around. Half your code will be pulling data, setting up, doing a bit of cleaning. You can't really do this. The other really exciting bit of ability it adds for the trusts is to secure data sharing. So the big example is integrating more tightly with the ICB. If I want to share blood results to Southeast London, it is a huge hoo-ha. It's essentially impossible. But data can be physically stored at GSDT. And also the example I'm going for here is if I want to touch or process GP data, I don't physically per se have to move it. I can query it from a warehouse, a bit of compute, go to Southeast London, and then give myself the results. And this can be done both ways. So we can get GP data from Southeast London and push secondary care data back in a secure fashion. The data remains and lives in Southeast London's account or GSDT's account physically, but you can provision the ability for people to scan over it safely. Being on the cloud, being on Snowflake gives you much more modern data engineering tools. So long gone are the days of SAM Designer, which I have a hatred of. But you can use DBT or declarative tables, which will keep themselves up to date in a more modern way. It's less to manage because it sort of manages itself. I mean, this is just an overview. You can OpenFlow is actually Apache NiFi, which is managed for you. So that's for ingesting data from disparate sources, but then the transformations can be handled all in one place without the need for other lesser tooling. We are the AI center, so we're going to talk about AI and language models. At present, if we want to use a GPU, it's up to date. So if we want to use a GPU, you have to install in the very limited amount of space we have another GPU. This GPU died recently. It took several months to replace it. It's just the way it's hard to do stuff on-prem with lots of GPUs. They're expensive, they're noisy. Apparently noise in a data center is a problem, and so on. If I want to create a new GPU or a compute instance to use a GPU, it takes literally 1 second. You can get different sizes and different numbers of them. It's immediate. And yeah, from that, we can begin to do cool things. So you could have for example, Joe's Uncle Armor model served to the public in a safe way using Snowflake. So here's a node endpoint you can send queries to and send inferred results back. And that's just one example. We can do much more with language model research at GSDT as a result. So this is demonstrated at Snowflake World Tour. It's kind of rogue. You could do AI join, so you can join on images like this. So like a normal chest X-ray. I'm like, this is slightly suspect. I'm like, this is a cool idea, but like you're missing many steps in terms of validation. But you can actually do this kind of thing. You could essentially take an embedding of a chest X-ray and find things that are like it. I don't know how useful that is in the real world, and there's probably a huge expense tied up with this, but it's doable. This is maybe a more like reasonable-ish thing, is you can do AI aggregation. So if you have a database of PubMed, so clinical trials, whatever, summarize the top insights for these studies and then aggregate them into some form. So studies will be grouped together. Again, I mean, like, I'll believe it when I see it, but cool that you could potentially do stuff like that. There are a few examples I can think of where people wanted to expose the outputs of their models or their data sets that they've created. At the moment, it's hard to do this in a trust and a safe way. You can do this with Streamlit, which is a Python-based UI thing you can use. Here's PhenoLab, which is a tool which we built, which can be deployed. Here it's deployed in Southeast London, but it's embedded as part of the platform and done in a safe way. There's much more. I've talked about scale. I've talked about being a SaaS, so it updates itself. If you want, as the Snowflake engine improves over time, you get speed improvements for free. The SQL language evolves for free without having to do SQL Server upgrades. Yeah, AI agents I didn't touch upon, but Snowflake are pushing for hard, probably very expensive. We can do secure data sharing with row access policy and similar uses. Role-based access control sounds boring, but this is all quite important if you're wanting to do this stuff at a larger scale. So in conclusion, I think it's highly exciting. I hope you agree. It unlocks scale and ability for us to share the data assets that the trust has made. I hate the term democratizing data, but I think it's true in this case. It's the first truly like big cloud project I think has been done at the trust. That okay, the EDW was, but it wasn't really managed by the trust in the way that this will be. So much to do in terms of population health, more data science capabilities, language model experimentation, and I think it's the largest kind of project in the NHS has been done. Okay, Imperial's done it, public health in Scotland's done it, ICBs have done it, but not to the scale in terms of integrating primary and secondary care potentially. Few ideas. If people want future teaching, we could organise a bit more, which is Snowflake oriented, because we're going to have more people joining and moving from other teams or from other use cases. QR code feedback for those who are so inclined. But thank you very much. Does anyone have any questions? Oh, Chris. Oh, hi, Chris. I didn't see you on the call.
Yeah, thanks, Lawrence. That was really good. I've just come from the Joint Apollo Information Governance Group, which is good about sharing Caboodle data a bit more widely for a couple of projects. So hence Ben and I were a little bit late. Yeah, I just wanted to say this is just to build on what you said about the scale of this project. This is trust-wide. It's not only trust-wide, we're already speaking with King's and with Lewisham and Greenwich about them joining this environment. So, you know, potentially we will have a secure data environment built in Snowflake that is contracted through GSTT with access for KCH and LGT. The piece that you talked about in terms of being able to query data at rest in Southeast London or the London Data Service is really important. And particularly you and I were on a call this morning around getting access to identifiable data, which we're going to need to carry out our integrator role. So I think my message is that we have to take every advantage of this contract. We have worked really hard over the last year to get this over the line. We've done it within existing budgets. We've done it without asking the trust to spend any more money. It will generate savings in what we would have spent if we'd stayed with the current environment. But we need to be able to evidence and return, you know, our bang for buck. So it's really important that the AI Centre, the clinical analytics team, health informatics, the other trusts when they join, work collectively on this project to make sure that we can evidence why we are spending, you know, millions of pounds of public money when, you know, a Daily Mail journalist can say, well, why couldn't you just buy 10 more X-ray machines? It's really important that we do that. So I think my message from a non-technical perspective is please capture everything you're doing, try and build the benefits analysis in, work collaboratively across teams. This doesn't belong to anyone. It's funded by the Chief Medical Officer. It won't work unless we have really positive cooperation with people like DT&I, and they're already helping immensely with the high level design and how we deliver this. The AI Centre, etc. So it's a joint trust asset, and it really has got the potential to be NHS leading, if not world leading, in the way that a very large secondary care organisation manages and uses its data. So yeah, just a bit of a sales pitch from me, but very excited.
Agree entirely. Nothing to add.
And we're not funded by Snowflake. We give this talk.
No.
No conflict of interest. I think Hugh put a hand up.
Yes, Hugh.
Lawrence,
I've
maybe
got,
take the slides off because we can all see the slides still. Just thought might be good.
I've got a bit of a geeky question.
Sure.
Ultimately, the data is saved on something. So
Yeah.
how do Snowflake get around the fact that at some point, if you think about this as a Turing machine, your head of your Turing machine can only be looking over one bit at a time. So when you've got multiple people wanting to access something on the same disk, how does it actually deal with that fact rather than just putting everyone in a queue and saying, right, you're first, you're second, and so on?
So it's the big did you my slide which showed the line, the separation of compute and storage, because the storage is something so like their RAID arrays, which can read and write data much faster, which are replicated across different availability zones within the cloud. This is all cloud infrastructure stuff. You're not tied to exactly the problem of a single disk putting stuff in a queue and having
so the data is copied like several times in the cloud, like there'd be several identical copies of the same data.
Yeah. So there's that, and also where what it's stored on is just designed for much faster read and write. So the technology is better and it's scaled for that. And then you can have multiple instances of compute float on top of it, and they're non-blocking. So it's just an ability in the cloud, the whole object storage paradigm. But yeah,
But at some level, there is ultimately like you could like DDoS yourself if you really wanted to, if you like made millions of requests at the same time.
you could, but there's a whole hyperscaler argument there because Microsoft and AWS are so large, they just sort of absorb the level of query. It's quite hard to DDoS, and they can rate limit you as well. So you'd be quite hard pushed to do it.
I mean, I meant more in theory, but yeah, I was wondering if there was some smart workaround, but there isn't. It's still just very efficient ways of reading disks.
Reading, right? Yeah, exactly.
It's not, you can't do DDoS in theory anymore because it's not a single node that's a bottleneck. It's multiple different entries and exits. So
you're up against a very large competitor to try and do it. You try point.
Is the goal to replicate this on-prem?
No.
In the installation? Okay. So we're not requiring the trust to back that compute.
So it also no, it's not. The long-term archive is hosted there. So no, it's immutable. And Snowflake internally replicates it to other sites for like disaster events and stuff.
Because so as per the last question, you obviously do get those benefits if you have the compute backup.
Yeah. So
depending on what the contract is, usually geography, how
exactly
separated, what level of earthquake proving,
all that kind of stuff,
etc.
And uptime guarantees.
Yeah. Any other questions at all?
Snowflake versus Databricks. You mentioned that Databricks was a comparator. What has persuaded you that Snowflake is the better option for?
It's a fair question. They fundamentally do the same thing. They roughly cost the same price. It's like those arguments are kind of moot. Most of the work the trust does in terms of data warehousing, etc., is SQL oriented, and the SQL interface and the ability to do stuff in SQL and Snowflake's a lot more powerful. There's also the other huge sell that it integrates super nicely with the rest of London. So your ability to become an integrator with ICB is essentially there's no friction, and all the audit and other like governance aspects come for free. Whereas you can technically do it in Databricks, but then you have to start talking about Iceberg or Delta tables and like, you're setting up blob storage accounts and they're theoretically safe, etc., etc. Chris might want to add to that as well.
The best SQL.
Yeah.
Sorry, just so that people are aware, we did go through a tender process for this. So it was actually evaluated. Lawrence was on the evaluation panel. Joe was as well. So it went through a Crown Commercial Services tender. So we didn't go in with a predetermined view that we were going to come out with Snowflake. We just wanted a data lakehouse capability to replace the EDW. And it was, it was a fair process and actually reasonably close in the outcome. But I think we've made the right call.
It's also the extra argument of if the rest of London's on it, you kind of create this common community pool of knowledge. Whereas if you begin to fragment everyone, and there are pros to fragmenting and having diversity in who your suppliers are, I think there's like having a core common SQL, like Snowflake strong community is very good. And sorry.
And just follow on if I may. So it sounded like in terms of prior deployments, you said Imperial had deployed Snowflake.
So in the NHS, Scotland's like public health, I don't know how their data volumes are probably comparatively quite small. Manchester ICB has it. All the London ICBs have it. Southwest does, but like to a lesser extent. I think that's it. So it would be Imperial and the Northwest ICB do, but they're comparatively small relative to. So it's biggest in the UK for sure.
And in terms of ICB data, is that like primary care data?
Care and SAS data,
And SAS,
Okay.
For now. And some community like Slam and other
No, it's not.
Paragraph.
It's not there yet. No.
Not yet
Mental
there.
health and social care is not yet.
Not yet.
So the big advantage of that, Sanjay, is Imperial have so connecting kind of secondary care data to primary care as well is in the trajectory of what we want to do. And one of the things that Snowflake as a platform allows us to do is have a kind of segregated places, sort of sandbox that when a project has approval, you can then share the data between different NHS trusts or different ICBs and secondary and primary. But I think it is a fair point that while we don't want to have like a market global domination, it is really, really important, in fact, and helpful to have a single platform across London, for example, where we can look at things now as at a population health level, you know, so and share resources, share skills, etc.
I was going to ask that in terms of, I guess, provider implementations, are there examples internationally where Snowflake's been deployed, and do we have an idea of what's gone well, what hasn't gone well?
Good question. A lot of it has been deployed with Epic in the States.
Yeah.
I know a lot of people use their I'm not sure like what has or hasn't gone well. I think masses of badness has happened, but yeah, it's been used quite a lot around.
Chris, sorry. I don't know if it's a latent hand.
Chris, is that a latent hand? Or
Oh no, sorry. I think you actually answered the question, Lawrence.
Oh.
Yeah, there are instances of large hospital groups in America using Snowflake in conjunction with Epic and Cerner, depending on what their EHR is. So lots of examples on that. And we will be able to join more formally a Snowflake community once we're up and running. This project has got the attention of the sort of highest echelons of the Snowflake management across the world, because they're seeing this as a very positive development. So I think we've got a lot of opportunity to be groundbreakers in this space.
I'd also like to pick up on Chris's point, which is that now that we've got Snowflake, let's work collaboratively, etc. I think the model inference, because we built and run models, that's our job, and model inference, writing it back and therefore serving it back is much easier, right? Because the ML ops and trying to get model to front end is very difficult at the moment.
Near impossible. So yeah, you're exactly right. OMOP or the expert data collections or the on-column outputs then immediately becomes a shareable data asset for everyone. Yeah.
And then rather than polluting and instance, exactly. Ben has a hands up. Thank you.
Yeah, so on a similar point, so it has been described to us that it is possible for Chronicles, which is the backend database of, well, backend database system, it's not a relational database as far as I know, of Epic to interface with external data sources. So one of those external data sources could definitely be the SDE with some of that machine learning stuff in it as well. So you could do your ML ops, machine learning modeling, save the outputs in the SDE as structured data and send it to Chronicles if that's what you wanted to do, and then connectivity was enabled.
Looking forward to it. Yeah.
Just to jump in, if I may, just one, not word of warning, but so that we don't scare the horses, so to speak. Obviously, this gives us an opportunity to share data easily, to have the same data sets, to get used to the principle of using the same data for different purposes. There are groups within the trust who are used to having siloed data because it enables them to have control of that data. So we have to not go at the pace of the slowest, but we have to bring people with us to understand, and that means effective governance. So the program board for this project has now been set up. First meeting is in early November. We will be formalizing a sort of SDE user group with health informatics, clinical analytics, data science and AI, research, etc., joining that group, and crucially information governance. who will want to see that, you know, we are applying the correct rules at the right time when we're using PID. You know, do we need to apply for a section 251, or is it all covered because it's direct care or service evaluation? When is it research? Do our Jerry and CRAG processes apply, which they will? So it's, I'd say, not a word of warning. We just need to be aware that there are governance things to clear up here. But this is a great opportunity to reset that governance relationship with a new extra epic data environment. So we'll be looking to get everyone's support on that.
Fantastic. Any other comments, any other questions from anyone from online or in person?
Cool.
Yeah. Great. Thank you.
Thank you guys
much.
so much for this. I wonder, Teddy, as you're taking some tips or suggestions from the group about what would be useful, I found this fascinating, even though it was a bit nerdy for me. Obviously, I'm not that techie, but wonderful job. Thank you, everyone, and Lawrence in particular. So yeah, it would be great to hear from anybody who would like to contribute thoughts and ideas of what would be good next time. And I appreciate I'm not probably the target audience. It's great to have these technical sessions.
Thanks, Sigal. Much appreciated for your support. Yeah, so this is a new initiative. Do fill the feedback form. Send me, ping me with any ideas. Now that we have a high quality database, next topic, we're probably going to talk about complex data analysis.
Yeah.
Next month. But I'll keep you guys updated. Thank you.
Bye, everyone. See you soon.
Thanks. Bye.
Thanks, everyone.